Perfect. My name's Tyler Wright. I'm graduating on Saturday with a bachelor's in applied computer sciences. And then this is my capstone project. So my project name is Augmented, not Automated, why AI won't replace a cybersecurity professional unless you let it. And that last part's kind of the whole point of the argument here. Oops, sorry, I got to tab back. Alrighty, so kind of a quick roadmap. I'm going to walk you through the problem and why it matters, what the literature that I studied read, the system I built, and how I collected and analyzed all the data, what I found, and then I will show you the system running live, and then from there we will finish with questions. So the problem, AI tools have moved into cybersecurity incredibly quickly. Automated threat detection, ML-driven SIEM platforms, none of this is experimental anymore. This is just everyday standard life. And there's a big gap growing between how fast these tools are adopted and how professionals are being trained to use them. Too many practitioners are treating AI as the authority. The alert pops up and they just immediately accept it, and then the model says benign, they move on. There's no human interaction. So the goal is to get professionals who treat AI as a high-powered assistant instead of the final authority. And that gap between those two states is what this project's all about. And then why does this matter? 3 reasons. ISC2's workforce study found that over 4 million unfilled cybersecurity jobs are posted globally. So AI isn't eliminating this job, it's just changing what the job requires. Second, automation complacency. Decades of research in aviation and medicine shows that when operators overtrust automation, their own skills tend to erode. Parzum and Manzi documented this pattern across multiple industries, and now it's showing up in security ops as well. And third, the stakes in this field, one misdetection can mean a catastrophic breach. A few concepts kind of anchor everything together here. Machine learning in security operations, models are trained on labeled traffic to flag threats at a scale no human can ever match. The catch is they're pattern matchers, not reasoners. SHAP from Lindbergh and Lee is kind of the explainability technique. It tells an analyst not just what was flagged, but why it was flagged. CICIDS is the labeled intrusion dataset that I built and trained on for this project. Automation complacency, like I mentioned, is the documented tendency to lose vigilance as automation appears more reliable. And the human in the loop design philosophy is kind of what ties it all together. Building human judgment into the decision process rather than treating as just an optional override. And then the last definition really matters because a human who's technically in the loop but given nothing to act on is just a rubber stamp in the machine. So there's a ton of research on AI and cybersecurity and another mountain on what happens when humans over rely on automation. So what's incredibly surprising is how rarely these two conversations intersect. And that's the gap that this capstone wants to address. 3 findings from the literature set up my argument. Apruzzi and colleagues showed that intrusion-detected classifiers can be manipulated. Attackers crafted inputs that made malicious traffic classify as benign. So, an incredibly well-trained model is not the same thing as a reliable model. Parsuman and Manzi gave us the complacency framework. The more reliable a system appears, the less vigilant its operators tend to become. And Miller and colleagues took that into an actual SOC environment and found analysts already accepting AI outputs without a single review, especially when alert volumes spike and get really crazy. And that's when scrutiny matters more than ever. Then the second half of the literature points towards the solution. Corporo, Zhu, and Shea showed interface design is a dramatically underestimated factor in security ops. How information is presented determines whether oversight is genuine or just performative. Dolce-Vez and Kim argued explainability isn't a nice to have, it's a requirement for high-stakes systems. And Gunning's DARPA work showed that the explaining a frontline operator needs is fundamentally different from what a data scientist needs. And Vramanshi's AI2 system at MIT proved the concept not only works, it's combining ML with structured analyst feedback, measuring improved detection. But nobody that I've found has been able to put all 3 threads, technical, the human, and the explainability together in one practical tool for us, and that's what this is going to try to build. So my research question is kind of under what conditions does active human oversight of AI security tools produce measurably better outcomes than just passive automation? And the approach is to answer with a working system rather than just an argument. So I built a human in the loop security dashboard that tackles all those problems. And then I trained it on the classifier CICIDS 2017. It's an older one, but it makes more sense. And it makes decisions visible with SHAP. Excuse me. Route low confidence outputs to a human review queue instead of just acting on them instinctively, and log every analyst override so that the value of oversight can actually be measured in a visual way. The closest prior work I could find was MIT's AI2, and the key difference is the audience. AI2 is a research platform. This dashboard adds SHAP explanations and interface designed for a working security analyst, someone with security knowledge, but not, data science as a background. So the dashboard's 4 views, and each one maps a user requirement. So the threat classification display shows every record with its classification, confidence score, and SHAP chart. It answers the analyst core questions. Why was this flagged? The human review queue is the thesis of all of this. Anything below a configurable confidence threshold will land there instead of being immediately acted on by the AI. The analyst override log records every human decision against ground truth, and the performance comparison view shows precision, recall, and false negative rate for automated mode versus my human in the loop mode. Side by side. And that 4th view is the empirical answer to the research question, and you'll see all 4 really soon. So my stack, it was Python with scikit-learn for the classifier, SHAP for all of my explanations, and then I use Streamlit for the analyst front-end stuff. I use Panda for my data pipeline, and I used, again, the data chart from CICIDS 2017. This build ran in 4 phases across the quarter: literature and data prep, model development, the dashboard build, and then finally analysis and framework, and then all 4 phases are complete. So all data came from the secondary source, so no IRB was needed. CICIDS is a public benchmark from the Canadian Institute of Cybersecurity. Network flows described by 78 statistical features, every record labeled with ground truth. My experiment runs using a balanced 5,000 flow sample from the DDoS capture from that year, which is standard practice since the full data set is over 2.8 million records and very imbalanced. It's got headline accuracy on imbalanced data. And then after cleaning, there's 77 features split 70-30 stratified. And because the build is a system, not a survey, my KPIs are system metrics, precision, recall, false negative rate, queue size, and override outcomes. The analysis compares the classifier in 2 modes: fully automated, where every model decision is final, and that's the passive adoption, and then human in the loop, where everything under 0.85 confidence threshold gets moved to that human queue. One design decision I wanted to flag was the simulated analyst is deliberately imperfect. It's only correct about 90% of the time. Assuming a flawless human would have stacked the deck perfectly for me. And I also ran the comparison at 3 different maturity levels and the full training set, and then 5% and 2% of it to simulate a model facing traffic it hasn't seen much of. So 5 findings. First, the big headline: the model confidence concentrates errors. Records the model was unsure about carried error rates of 14 to 21%. Its confidence calls were wrong less than 1/5% of the time. That's roughly 100 to 1 concentration. Yet the review queue never exceeded 7.5% of the traffic, and it contained nearly all the records the model was going to get wrong. So cheap review, disproportionate coverage. Third, the mature model, human review cut false negatives at a cost, reviewing 0.5% of records. And 4th, the early stage model is where it gets dramatic. False positives cut from 21 to 7%, and false positives are what drive alert fatigue, which is the on-ramp to complacency. And then 5th and finally, my favorite finding, because it cuts against my own thesis: the imperfect human occasionally flipped correct decisions to wrong ones, and wrong ones the right ones. And putting a human in the loop is not automatically a win. That human's value depends on the quality of information they're given, which is exactly why this dashboard is built around SHAP and not bare approve, deny buttons. So all the way back to the problem statement, AI tools are being adopted as these authority figures, while professionals are trained as spectators. And what I wanted to build is a system where oversight is a design feature, not an afterthought. And the results back my argument. Confidence reliably flags what the model will get wrong, and routing just that, uncertain to a human improves outcomes, and a poorly supported human adds errors of their own. So the the answer to all of this is not simply to just add a human, but it's to give a human something meaningful to work with. And that's the framework this project leaves behind. Delegate where the model has earned it, route uncertainty to the people, and invest in explainability so those people can exercise judgment. The professionals who work this way aren't competing with AI. They're the reason that it works. Tab out here and switch over to my actual thing. So you can see the security dashboard here. This is all of the scan threats that we'll be using for this demo. So just showing you how they change based on what the AI has decided. Its confidence is 100% that it's a benign threat, no big deal. Malicious, 100%. And we'll switch back to that. First we need to change this up to 95 just to increase the review. Okay, so these are all the events that get flagged for human interference. So let's say record 96, it says it's benign at only 59% confidence. I look at this chart and it screams something weird's going on here. So for something like this, we can either accept the model, which gives AI permission to push, or we can override. I have escalate here in case you had a supervisor you needed to report to first, but we're just going to override to malicious. Same thing here. It says benign, 88% confident. Incorrect. That's also isn't going to work. Oh, that's good. I was supposed to hit override there, but that's fine. And then record 295, 89% confidence. This guy's good. 24 also good. Then this is always this is a great example. It says it's benign and it's only 69%. So it's why trust this? But the big reason this isn't as confident is its destination port's all messed up. This is just its HTTP port. This is just the normal internet configuration. So the AI tripped up on it, but this is totally fine. Not going to go through the rest of these. It would take too long. So then after the human makes all his or her changes, normally this would say error is caught by human review 2, but I misclicked, so it's only got 1. So this just showcases the exact actions that the analyst made at the time. And then at the very end, shows you exactly the difference between the fully automated and then the human in the loop. Yeah. All right. These are just all my references. And then any questions?
Good job. That's cool. I like it.
Thank you.
How did you determine what the threshold is for what is considered benign versus malicious? Did you say something or think of like if it's below 70% sure or unsureness, if you will, then it's considered like what's your threshold number? How did you decide that?
So originally it was just pure 90%, but then it kind of trips up the AI and doesn't give it anything to look at. So it cuts down the malicious threats because whatever its threshold is, it doesn't showcase that to us. So then by cranking it up to 95, it just gives more credence to the human interacting with it. And it's something I would imagine that a business would do to make sure they're not exposing themselves.
Gotcha. So if the threshold's too low, then you can end up with a lot of false negatives, basically, or false positives.
Absolutely.
Gotcha. Cool. I love how you explained that. That was really good.
Does anybody else have any questions? Emma, Jenny, you guys have any questions you would like to ask Tyler?
I'm good. It's really good. Impressive.
I'm good. Thank you.
Awesome.
Good
Thank
job,
you, guys.